solution and what's something that can be called as a solution. What's something that can be called as a solution? So first of all, solution is going to be a mixture, and whenever you have mixture, you will have at least two things, right? You'll have at least two components or two substances. Now, but a very peculiar thing or something that you have to remember about solution is that it is a homogeneous mixture. It is a homogeneous mixture. So please write, what is solution? Homogeneous mixture of homogeneous mixture of two or more components. Okay, two or more components. Acha, there is one more announcement. Okay, one more announcement. The announcement is that next class, that will be on Wednesday. Wednesday, the class will be at 4 p.m. KSA timing. Okay.
Which timing?
Saudi Arabia. KSA Kingdom, and it will be 6:30 according to IST. Indian Standard Time से ये this will be 6:30. Okay. Fatima, आप अभी कहाँ है वैसे? You are in India or?
No, I'm not in India.
You're not in India. You are in Kuwait, ना? I think.
No.
No, दमाम में आप, right? नहीं, फिर कहाँ है? I forgot.
Bahrain.
अच्छा, you are from Bahrain. Is this your first class?
No.
नहीं ना? Okay. Then I am अच्छा. Okay, Ibn al-Haytham, Bahrain में?
नहीं sir. Indian school.
Different school. Indian school. अच्छा. ठीक है. So I was mistaking you. Fine. Okay,
sir,
so
there
Wednesday.
are two Fatimas.
There are two Fatimas. इस क्लास में नहीं है लेकिन ना?
अभी नहीं.
Not in this class. अभी नहीं है. हाँ. Oh. हाँ, ठीक. There are two Fatima. So you're Fatima Ansari.
Yes.
One is Fatima Munir. वो अभी नहीं है. हाँ, वो आती थी क्लास में. ठीक है. Right. Thank you. वो भी नहीं आई है 2-3 क्लास से. Okay. So आपका टाइमिंग तो सेम रहता है ना? किंगडम की टाइमिंग से, है ना?
हाँ sir. Sir, but that time I have another class.
क्यों?
Not tuitions.
तो?
Other class.
What other class?
I go to karate, so I have that class also.
Okay, so on what days? Monday and Wednesday?
Monday, Wednesday, and Saturday.
Monday, Wednesday, and Saturday. What's the timing for that?
5 to 6.
5 to 6.
Yeah.
तो आई थिंक आपको फिर नहीं तब तो फिर दिक्कत होगी ना, लाइक आपको जल्दी आ जाना पड़ेगा. आज आप 5 to 6, आज आप कैसे आ गए? अभी कितना भाई? अभी
मतलब I didn't do, I skipped that class.
You skipped that class. Okay, तब तो आपको लर्निवियो में ना बात कर लेना पड़ेगा टाइमिंग के बारे में. ठीक है फातिमा?
Okay sir.
है ना, आप बता दीजिए कि आप कैसे से क्लास होता है, या नहीं तो यू आस्क देम कि वो आपको थोड़ा जल्दी छोड़ दें. आई डोंट नो वेदर इट कैन हैपन देयर और नॉट. ठीक है, कहीं
But
पे भी
sir,
आपको
if I leave early, then I will miss a little bit of class, right?
you will be missing the karate class ना.
No. अच्छा, okay, leave from there.
हाँ, you leave from there early. अरे अभी आप मतलब like 11th 12th में क्यों? When did you start practicing?
When I was 7 years old.
तो क्या black belt बनना है आपको? हाँ?
Of course.
Of course, okay. That's the goal. Okay. I have one friend. I don't know if she is a black belt or not, but she is also very much enthusiastic about karate. She's like, karate ने जितना मुझे सिखाया उतना किसी चीज ने नहीं सिखाया आज तक. Okay, let's move on to solutions. So homogeneous mixture of two or more components. So let us now describe the components here. Okay, so what are the components of solution? So it is called is it martial art? इसको martial art कहा जाता है कराटे को?
Yeah, it is a type of martial art.
It is a type of. Is it the easiest one?
Well, I don't know because I haven't done others.
Actually, you haven't done the others, you don't know. So there is one component that is solvent, and I will be representing solvent as A. कोई और है यहाँ पे जिसको UFC में जाना है? Is there anyone here who has done some practicing? No, no one. Okay. क्या इसको sparring बोलते हैं ना कुछ तो शायद? Do you guys spar in karate
I
also?
think, yeah, it is
Spar.
there in karate. Sir, your
There.
friend is doing it from which
हो गया
institute?
उसका हो गया. Like she
Black
was
belt.
doing in, I think so. I mean, देख के लगता नहीं है, but I think so. Okay.
Okay, but like, do
अच्छा
you know which academy institute
which academy? वो ये दिल्ली में किया था ना उन्होंने.
and which type?
नहीं नहीं इतना डिटेल नहीं पता. पूछ लेंगे क्या उससे हम?
Okay,
Should I ask her? Okay,
yeah,
fine.
sure.
I will. Okay, fine. I will ask her. Okay. अच्छा, Rishan is also here. Assalamu alaikum, Rishan. Rishan, how are you? Yes, Rishan. आप क्यों कर रहे हैं ये क्लास? लाइक आपने तो सारा क्लास किया हुआ है इसका, सॉल्यूशंस का. नहीं? Yes or no, Rishan? I think you have done all the classes, right? Okay, you answer me in chat. Baki, rest of you, right? What is solvent? Solvent is the component in major amount, major or larger amount. हाँ ईशान सर कहा है, बस आपने बताइए, आगे बात बताइए. लार्जर अमाउंट. आई चेंज टाइमिंग. टाइमिंग तो चेंज कर दिया आपने, ठीक है. ओके. नेक्स्ट इज सॉल्यूट, दैट इज बी. असाइनमेंट्स किए हैं आपने? यू आर प्रेजेंट इन यस्टरडेज क्लास ना ऋषान? 5:30 की बैच से 4:30. 5:30 की बैच से 4:30. 5:30 का तो बैच ही नहीं था. अच्छा ऋषान, आपने असाइनमेंट किया है कि नहीं किया, ये बताइए जरा. अभी तक जितने असाइनमेंट मिलने हैं आपने किया है? हाँ. सो डू वन थिंग, प्लीज डू दी असाइनमेंट, है ना. आज आप क्लास मत कीजिए, ठीक है, बट प्लीज डू द असाइनमेंट, दैट विल बी मोर बेनिफिशियल टू यू. यही बार बार एक ही चीज सुन के आपको कोई फायदा नहीं होने वाला है ना. कंपोनेंट इन lesser amount. Okay, so solvent that I will be representing as A and solute that I will be. लेकिन क्लास अगर आप छोड़ के जाइएगा तो असाइनमेंट हमको मिलना चाहिए, ठीक है. प्लीज सेंड दी असाइनमेंट्स. ओके निशान, असाइनमेंट्स मिलने चाहिए हमको अगर आप क्लास छोड़ के जा रहे हो तो. हाँ, वेरी गुड. Okay, so solvent and solute. Solvent that is present in larger amount or major amount, and solute is something that a component which is present in lesser amount. But please remember, solvent will only be one thing. Okay, there will be only one thing which will be in the largest or the major amount, and there can be many other solvents, many other solutes. One more thing that I will write here is about binary solutions. Binary solution. So binary solution, a solution with only two components. A solution with only two components. Okay, so we will be learning only about the binary solutions. Okay, we'll be learning only about the binary solution, a solution in which we have only two components, A and B, solute and solvent. Solute, which is mixed inside the solvent. Now, whenever we talk about solutions, whether the solution is going to be of sugar and water, right? Or it is going to be glucose and water, or it is going to be of salt and water, right? Or even if you have concentrations, even if you have solution of any different kind, there are two things which are important about solutions. Okay, I have A, B, and C. Now listen very carefully. Don't write anything. Okay, so what I am going to tell you now, it is very important, not only in terms of solution chapter, but in general science, in general, and most importantly in chemistry. Whenever we talk about things, we try to see what differentiates them. है ना? We try to see what differentiates them. A person who doesn't understand the difference between a laptop and a computer, even though all the minor components, that means the microscopic components, are same for all, each and everything, right? Microscopic components means we have proton and we have electrons and we have neutrons. And everything is made up of protons, electrons, and neutrons. And means, is everything same? No, everything is not same. We humans have a tendency to classify things, and we can differentiate things on the basis of many different. For example, you drink A and you found it sweet. You drank A and you found it sweet. So you will say that, okay, fine, it is having sugar. Okay, it is having sugar. You drank B and you found it salty. You will say that, okay, fine, this B solution, it has in it some salt. So this is how you are differentiating. Then you went and you drank C and it was also sweet. Then does that mean A and C solution are completely same? Yes or no? What do you think? Can there be any other difference? I found it sweet, A, and the C solution also I found it sweet. Tell me. Alida, Fatima, Rushta, Sara. Rushta, bataiye. Rushta is new here. Rushta, what do you think? Can there be any other difference?
Yes, sir. The amount.
Amount, right? So, kitna sweet hai, right? What is the level of sweetness there? Now, there comes the most important point about any solution, that is the concentration of the solution. And there are various ways to represent the concentration of solution. So, write concentration terms. Concentration terms. The first concentration term that we will be learning, most of the concentration term that you will be learning in this class will be the same as whatever you have learned in 11th standard. So you must know and you must recognize this concentration term, that is mass percentage. Mass percentage, okay, that is W by W. फातिमा, आप हमारे साथ 11th में थी क्या?
नहीं sir.
नहीं ना? So no one was here. I think only Sarah was with us in 11th standard, right, Sarah?
Yes, sir.
Only Sarah was here. Okay. Mass percentage. So what is mass percentage? You can write mass percentage is equal to. Okay, only this coming. Mass percentage, it is equal to mass of a component divided by total mass of solution, and we will multiply this by 100 in order to get the percentage. For example, if I have a solution with WA amount of A and I have WB amount of B, then mass percentage of A, it will be equal to the mass of component A divided by the total mass of solution will be the mass of A plus mass of B. And then we will multiply this by 100. Even though this is the formula, but most of the time in the numericals, you will not be creating this type of very easy numerical in which you are given the mass of A and B, and then you have to calculate the mass percentage. What you will be using, you will be given the mass percentage of a particular solution, and then you will have to convert it to molarity, or mole fraction, something like that you will be given. So what is important to translate the information that is being given to you. You will be given, for example, let us suppose you have been given 10%, please listen very carefully, 10% W by W of aqueous NaCl. Now, this small phrase, it gives me the information about that 10 gram of NaCl is present in 100 gram of solution. So this is one of the translation that I can get from the statement above. Another translation would be 10 gram of NaCl is mixed with 90 gram of water. So it has also given me the information of solute as well as the solvent and the amount of both the things and the masses of both the things, right? Yes or no? How much solute is mixed with how much solvent? Please write this down. Let me know when you are done. Is it clear with everyone? Yes or no? Yes, Alida, Adriel, Rushda,
Sir.
Huzaifa. Yes,
Yes,
na?
sir.
Okay. Sarah, you have seen this earlier, पहले भी, है ना? Were you present with some basic concepts of chemistry? आपने उसका recording देखा था, Sarah?
I started like in December and this month.
अच्छा, दिसंबर एंड में आपने स्टार्ट किया, तो टर्म 2 पढ़ा है फिर आपने सिर्फ, है ना?
Yes.
तो ये सारी चीजें नहीं है फिर आपके लिए, आप भी ध्यान से रखिए इसको. So these type of translations, what I say na, 11th standard mein, we have some basic concepts of chemistry. That chapter is like the grammar of chemistry. It is grammar of chemistry, and it is telling what is the language the chemistry uses. The whole chapter is based on that. So in that chapter, I focus on translations. Translations means you have been given some chemical information and then you translate it to simple English, जिससे आपको clear बिल्कुल समझ में आ जाए. So these type of exercise we have done in 11th standard बहुत ज्यादा, लेकिन आज भी फिर करेंगे इसमें भी. Also there will be one question on stoichiometry that we will be doing in the next class, है ना? So stoichiometry with that is related to solutions. चलिए, let me know when you're done. You have to raise your hand. Okay, so those who are using laptop, they can press Alt and Y at the same time, and then your hand will be raised. Okay, and those who are using phone, they can go to somewhere in the phone, I don't know. Okay, Sarah is done. Waiting for Adriel, Alida, Fatima, Huzaifa, and Rushda. Okay. Okay, waiting for Huzaifa and Rushda. Rushda is done. Rushda, where are you from, by the way? In India? Are you from India?
Yes, sir. I'm from India.
Where in India?
Hyderabad.
Acha, Hyderabad. Great. And you were born in Riyadh only?
Yes, sir.
Acha. Okay. So can I move on? Yes or no? Please tell me. Anna, Huzaifa is, everyone is done, na? I can move on. Okay. Write the second one. Volume percentage. Volume percentage, and it is given by V by V. Okay. Now, look at mass percentage, है ना? And replace the mass with volume, and everything else is going to be the same. Everything else is going to be same. Okay. बस ये कीजिएगा कि WA की जगह you will write that volume is what? VA. Now volume B will be what? VB, right? So you can adjust and you can write your own definitions. ठीक है? Look at mass percentage and try to write it in your own words, and you can just copy whatever I have written, but you will just copy till here. Okay. Example I will be giving you. ठीक है? Example I will be giving you about 10% V by V of what? Write this down. Let me know when you are done. Okay, just waiting for Huzaifa and Sarah. Okay, great. Now let us look at the example. Let's look at the example. Okay. Keep in mind the example that is there for mass. ठीक है? Keep in mind, and then you need to extrapolate it. उसके बारे में सोचना चालू कर दीजिए अभी से ही आप, है ना? Whatever example I will be given, what will be its translation? So I will be given especially 10%, The only thing that I will be changing is V by V of, now I have to take some, I have to take volume, right? So I have to take liquid. So ethanol is a liquid. So if you have 10% V by V, that is 10% volume percentage is given 10% of ethanol. So it will be translated as 10 ml of ethanol in 100 ml of solution. Or there can be another translation which will be 10 ml of ethanol mixed with 90 ml of solution. Please write this down. Of solution. Is it clear? Yes or no? Everyone, Fatima, Rashta, Adriel, Alida.
Yes, sir.
Clear, right? Okay.
Yes, sir.
Yes, sir.
Now, there is a similar term which is known as mass by volume percentage. You don't need to know what is the formula for volume. I think, and I hope you have written the formula and all. But for mass and by volume percentage, there is another mass by volume percentage. It is given by W by V. Okay, W upon V. Now, I will just give you an example and its translation that will be more useful for you. If you have been given 10% W by V of aqueous, ethanol is also going to be aqueous. And if aqueous is not given, then also you will assume that it is that the solvent is going to be water. W by V of aqueous NaCl. So it means that you can only do one translation here. The only translation that you can do is 10 gram of NaCl is present in 100 ml of solution. Okay, 100 ml of solution. You cannot write like this. If I want mass of salt, or if I want volume of H2O, then I can't write. I can't say that it will be equal to 100 ml minus 10 gram now, because subtraction with different unit, it is prohibited. You cannot subtract if you have different units, right? Unit dimensions and measurement, that is the first chapter of physics. In that you must have learned that you cannot do addition or subtraction using two different units, right? That is why you cannot tell what will be the volume of H2O. So the only translation that you can do in this case is what 10 gram of NaCl present in 100 ml of solution. Is this clear? Yes or no? Please tell me. Is this clear, guys?
Yes, sir.
Okay. Now write next question. Write a question. Calculate the mass percentage 6 into 10 to the power minus 3 grams of oxygen present in 1 liter of seawater. The weight of seawater, 1 liter of seawater is going to be 1030 grams, because seawater is a bit heavy because of the presence of salts. Okay. So this question is easy. Mass percentage, it will be equal to mass of oxygen divided by mass of seawater. I know what that is, the solution, into 100. Right, so this will be equal to 6 into 10 to the power 3, so 10 to the power minus 3 divided by seawater is 1030. So this will be also grams, this will be also grams, into 100. Grams and grams will cancel out. And also percentage do not have any unit, it is just percentage. So calculate this value, and expand it. Okay, aise mat calculate kijiyega, you expand it like this. It's 6, so this 103 will be getting cancelled like this. So 6 upon 103 into 10 to the power minus 3. Calculate what is 6 upon 103. Calculate what is 6 upon 103. Don't use calculator. If you Alida, 6/103.
Actually, yeah, I actually did it. I got the final answer.
Final answer ये है आपका 5.8.
No, into 10 to the power minus 4.
Okay. 5.8 into 10 to the power minus 4, and there will be a percentage here. Now, does this look weird? Tell me yes or no. Imagine a percentage in which you have been also given the exponents of 10. If this is present in some label, okay, imagine this. इसको ना हमेशा, please remember everything. Whatever you are going to study now, whatever you are studying right now, this all have been studied only to make products. Okay, there will be some product जिसमें concentration terms इस्तेमाल होता होगा. That is why they are teaching you concentration terms. Okay, so at the now tell me, you have been given this concentration term 5.8 into 10 to the power minus 4 mass percentage. Okay, also remember one more thing, when they are saying mass percentage, so they are appealing to the mass audience, that is public, general public, है ना? General public mean they will understand what is mass percentage. They understand what is mass. They understand, every layman, they understand what is percentage also, right? But imagine telling them in this way, 5.8 into 10 to the power minus 4 percentage. If you set them 5%, they will have an idea what does it mean. Kitna solute है इसमें, कितना नमक है इसमें, कितना चीनी है इसमें, right? But will they be able to understand this number? Yes or no? Tell me. Or will it be difficult for them to digest this number? Difficult or easy?
Difficult.
Difficult, है ना? Difficult, right? And that is why for the solutes or the solutions in which the solute is in very small amount, a new concentration term was introduced. What was that concentration term? किसी को पता है? What is that concentration term? For very minute amount of solute, it is parts per million. Parts per million. Okay, so parts per million, ppm. So what is a ppm? ppm, it is equal to parts of a component that is divided by parts of a component that is divided by total parts in solution or off solution, right? Anything in solution into. Now, when we were talking about percent, as the other figure, when we talked about percent, we multiplied by 100. Now we are talking about per million, right? Yes or no? Cent is 100, million is 10 to the power 6. So I will multiply this with 10 to the power 6. Yes or no? Clear, all of you?
Yes, sir.
Okay. Now what we will do, we will calculate the same thing, but we'll be using the formula of ppm here. Okay. Now see, we have 6 into 10 to the power minus 3 divided by 1030 into 10 to the power 6, right? So we will get 6/103 into, so we will have 10 to the power minus 3 and 6 here, so it will become 10 to the power 3, and from 0 1 will cancel and we will be getting 10 to the power 2. Yes or no? Correct, eh? Can all of you understand this simplification? Yes or no? Right? What about others? Alida?
Yes, sir.
Right?
Yes.
Okay, all of you understand that. You can lower your hand by the way. Okay. Now, if you simplify this, it will come as 5.8 and the unit will be ppm. Anna, what does this mean? And as soon as you say 5.8 parts per million, okay, easily understand that if I take a million gram, in that there will be only 5.8 grams of solute, 5.8 grams of solute. And this ppm is used in, one of the example is, they are used in paint. And in paints, ppm is used to get the concentration of lead. So the lead content in paint, it is given in ppm. And if a paint should not exceed more than 90 ppm of lead, because lead is poisonous, you know? That is why it should not exceed more than 90 ppm. So ppm is used in paints. Okay, ppm is used in paints. Please write this down. This calculation, parts per million, and then the calculation of parts per million. Is it clear, yes or no? The usage of parts per million? Tell me. I hope you can see the difference. Both of these things are talking about the same solution, but I can say that the ppm one is more humane. It is right. It is more human friendly, and this is more nerdy. Only a few people can understand what it really represents. But if I say 5.8 ppm, this message can be understood by many people. Parts per million. Okay. Please tell me if you're done. Please tell me if you're done. Raise your hand if you're done, okay? ऐसे बैठे मत रहिए, please. Raise your hand if you're done. Okay. Add real, done, na?
Yes, sir.
Okay. Right now. So these are all generally used for general public, okay? So all of these can be used. Mass percentage, volume percentage, है ना? And then parts per million. ये आपको ऐसे आम life में भी मिल जाएगा. Now let us come and get into the concentration terms which are more used in chemistry. The first one you will identify, that is molarity. All of you must have heard about molarity, right? Molarity, and it is represented by capital M. Even if you don't remember it, it's fine. Okay, we will write the definition also. So molarity, remember the one sentence, the number of moles of what? Of solute per liter of solution. You can lower your hands, by the way. Per liter of solution. Per liter of solution. So what will be its formula? Molarity, that is represented by M, capital M. It will be equal to the number of moles of solute. So for solute, I will write number of moles is N and B means solute, divided by the volume of solution in liters. Now its unit will be equal to what? Unit will be mole, it's for mole, and volume in liters will be mole per liter, or it will be mole per dm cube. Mole per dm cube. 1 dm cube is equal to 1 liter. 1 liter. Now, once again, we all know that number of moles is equal to the given mass of the solute divided by the molar mass of the solute, right? Molar mass of the solute. So I can further write this statement as molarity is equal to replacing the number of moles by WB upon molar mass of B, and I will multiply this by volume of solution in liters. Is that clear? Yes or no? Please tell me.
So what's the other unit?
Moles per dm cube, decimeter cube.
Okay, thank you.
Okay. Now, one thing to note here is that volume element or volume term is there in molarity, right? So since molarity has a volume term, it is temperature dependent. It is temperature dependent. Okay, it is going to be temperature dependent because if I am going to heat something, then the volume of liquid will expand. The liquid will expand, then the volume will increase. And if the volume increases, there will be some change in the molarity because volume is there, volume is present in the molarity. So molarity is not used in shipping contents. Okay. And if molarity is used in shipping contents, then they also mention the temperature. So you are producing something or you are synthesizing some kind of chemical in a laboratory, and then you are shipping it to some different country. So you will be giving the concentration not in terms of molarity, because temperature change होगा तो फिर molarity different आएगा ना, and they will be testing the molarity there. वहाँ पे आपको वो same molarity नहीं मिलेगा. Okay, so there are different concentration terms that you can use that we'll be learning after this. So there is one very famous chemical company, that is BSF, and there is one more that is in Ukraine, and right now still it is still working. People are still working there. So all of them, they use what they use molarity. Sorry, they don't use molarity, they use some different terms. They don't use molarity. Okay, please tell me if you're done. Please tell me if you're done. Okay, now a few more thing about molarity. शायद आपने शायद इसको पढ़ा भी होगा, नहीं भी पढ़ा होगा. There are few terms that you have to remember about molarity. So if I say 1 m, this represents 1 molar, and 1 molar, it represents what? 1 mole per liter. Now there are few terms that is related to 1 molar. 1 molar, similarly you will have semi-molar. Okay, if I say a molar concentration, that means 1 moles per liter. If I say semi-molar, it means 1/2 m. That means 0.5 moles or half moles per liter. Semi-molar. Then you have decimolar. This will be equal to 1/10 of a molarity. That is equal to 1/10, 0.1 moles per liter. Then also you have centimolar. Concentration of a solution is given as centimolar. That means it is 1/100 m, which is equal to 0.01 moles per liter. There is also one more, which is millimolar. Millimolar, which is equal to 1/1000 molar, and it is equal to 0.001 moles per liter. Chali. Now, try to write these things. Try to write these things. Then we will do one question. Also raise your hand when you're done. Okay, those who are done, they can write a question. Please write this question. 2.46 gram of sodium hydroxide, whose molar mass is 40, is dissolved in water, and the solution is made up to 100 centimeter cube in a volumetric flask. Calculate the molarity of solution. This is one of the simplest questions that you are going to get for the calculation of molarity, in which you have been given the mass of the substance. You just need to find out the number of moles of that substance by dividing it with the molar mass. Molar mass is also given, that is 40. You will get the number of moles. Then you have been given the volume in terms of centimeter cube. You can convert centimeter cube to ml. So 1 centimeter cube is equal to 1 ml. That is why I have 100 centimeter cube. Centimeter cube can also be written as cc, which means cubic centimeter. This will be equal to 100 ml, and 100 ml is equal to 0.1 liter. So you have got volume also. Just need to calculate the number of moles. Moles of NaOH, it is equal to the given mass divided by the molar mass. So the given mass is what? 2.46 grams. Molar mass is given 40 grams per mole. Grams and grams will cancel out. Please calculate this value. Acha, even if you don't want to calculate, ऐसे लिख लीजिए सीधा. उसके बाद molarity, it is equal to NB upon volume in liter. NV is equal to how much? 2.46 divided by 40 into. You have 100 ml, that is 0.1. 0.1, this means what? 1 upon 10 liters. You can write 1 here and then you can multiply 10 here. So this will be equal to 24.6 divided by 40 moles per liter. Please write this down. Calculate the answer. 24.6 divided by 40. Send the answer in chat. Uske baad we will be looking at molality. Looking at molality. Please send the answer if you have got the answer. अरे व्हाट हैपेंड गाइस, किसी का नहीं आया क्या अभी तक? नहीं सारा सही से कैलकुलेट कीजिए. 24 बड़ा है या 40 बड़ा है सारा? विच इज ग्रेटर?
Sorry, I divided it by 4.
हाँ ठीक है, तो फिर क्या बस एक आप उसमें जीरो आगे मतलब उसका डेसिमल पॉइंट के अंदर कर दीजिए ना. यू विल गेट 0.615 मोल्स पर लीटर. ओके, तो जो भी टाइम लगने वाला है ना आपको, आप कैलकुलेशन में टाइम लगने वाला है, कंसेप्ट में टाइम नहीं लगेगा, ये मेरी जिम्मेदारी है ना. It's my guarantee that you will not take much time in the conceptual part. You will be only taking time in the calculation part. Okay, and that is your responsibility कि कितना fast आप calculation कर पाते हो. Okay, now those who have not written, please write it down fast. 0.615. Next concentration term, sixth one, molality, given by small m. It is given by small m. One liner definition for molality will be the number of moles. The number of moles per kg of solvent. Now this is very important. We have the differentiating factor here is what? We have per kg and the kgs of solvent. Per kg of solvent. So what you can write here, small m, that is molality, it is equal to the number of moles divided by the mass of what? Solvent, that is why A is there, in kgs. Unit will be number of moles, unit is mole, the mass is in kg, so mole per kg. Okay, now you can further write this as number of moles is equal to the mass of number of moles of solute, it is equal to mass of solute divided by the molar mass of solute into the mass of solvent in kgs. Okay, now a few things to remember here is that this WB should be in terms of grams. This molar mass in B, it should be in terms of what? given mass of solute in grams. Molar mass of solute. Molar mass of solute in grams per mole. Okay, grams per mole. Please remember these two things. और ये तो आपका केजी में ही याद रखिएगा उसको. The next thing to note here is that you can see very clearly molality, it is not dependent on temperature because it does not have any volume term in it. Okay, so molality is independent of temperature as it does not have any volume term. Okay, please write this down. Let me know when you are done by raising your hand. I think it is clear with everyone, na? Why is it not dependent on temperature, right? Because volume का कोई role ही नहीं है molality में. You have only mass and number of moles. Number of moles is also only dependent on mass and the molar mass. So everything is mass here. Okay. Yes or no, guys? Adriel, Alida, Sara, Rushta.
Yes, sir.
Yes,
Yes,
na?
sir.
Okay, fine. Okay, great. How many of you are in touch with seniors? Seniors से बात करते हैं अपने स्कूल के 12th standard मतलब एक तो senior होंगे ना जो भी एग्जाम दे रहे होंगे. They have just started their boards right now. Is there anyone who is in contact with seniors? नहीं. No one. Okay. How many of you are still having online classes? Raise your hand now. How many of you are still having? नहीं अभी raise मत hand मत raise कीजिए. ऐसे thumbs up कर दीजिए if you are having online classes. नहीं किसी का नहीं चल रहा होगा. Okay. Write this down. Let me know when you are done. Raise your hand when you are done. Just waiting for Adriel and Huzaifa. Everyone is done. Great. Okay, you guys can lower your hand, okay? So, write this question. Calculate the molality of a solution containing 2.6 gram of potassium carbonate. What is potassium carbonate? Potassium carbonate is K2CO3. You have been asked to calculate the molality of a solution containing 20.7 gram of potassium carbonate dissolved in 500 ml of solution. Assume the density of solution is equal to 1 gram per ml. Okay. So the first thing here is that you have to calculate the number of moles of potassium carbonate because you have been given molality. You have been asked about molality. So let us first of all calculate the number of moles of potassium carbonate. Number of moles of B, that is the solute potassium carbonate, is equal to the given mass of potassium carbonate divided by the molar mass of potassium carbonate. What is the molar mass of potassium carbonate? It is equal to, potassium is how much? What is the molar mass of potassium? नहीं पता. 40 into 2 because you have 2 potassium, plus carbon is how much? 12, plus oxygen is how much? 3 into 16. Please write this down, calculate it, tell the answer in chat. What will be the molar mass? कितना आ जाएगा molar mass? Excuse me. Tell me what is the molar mass, guys? क्या हो गया? इतना टाइम क्यों लग रहा है? छोटा सा कैलकुलेशन है. 80 plus 12 plus 16 3 जा 48 ना. टेबल्स नहीं आता होगा आप लोगों को. So 80 plus 40 will be equal to how much? 121. Yeah, 80 plus 40 is equal to 120. नहीं 48 होगा ये. हाँ सही है, 48 होगा. Add this up, कितना जाएगा? Send the answer in chat. पोटाशियम, ठीक है. अब ध्यान रखें. Will you remember potassium is what? 40. ठीक है. लेकिन potassium you will always calculate as 40, but its accurate molar mass is 39. ठीक है. 40 याद रखिएगा, because 39 से multiply करने में लोग घबराते हैं. You have, I mean, you will be fearing and you will not be multiplying or dividing by 39. You always remember 40. उसके बाद आप subtract कर दीजिए. So we have done 40 into 2. And the real molar mass is how much? Real molar mass is 39. You can just subtract 2 here. Molar mass will be equal to 138 grams per mole. Okay. Potassium always take as 40 and then याद रखिएगा कि एक subtract करना है आपको for each potassium. So you have got the molar mass. The number of moles, it will be equal to, the given mass is how much? 20.7 divided by the molar mass, that is equal to 138 grams per mole. This is equal to grams and this is grams per mole. Grams and grams will cancel out each other and you will get the number of moles as 20.7 upon 138 moles. This is the number of moles of solute. Now moving on to the, we have molality. So molality, what is the formula for molality? Small m, it is equal to the number of moles of solute divided by the mass of solvent in kgs. So neither we have the mass nor we have the mass of solvent. Not that we don't have anything about the solvent. We have 500 ml of solution. Please remember, we have 500 ml of solution. It has been given the density is equal to 1 gram per ml. So we need to find out mass of solvent in kg. Mass of solvent, let us find out. बाद में kg में तो convert हो जाएगा. Mass of solvent. So I can write mass of solvent is equal to mass of solution. Please remember very carefully, listen very carefully, leave your pen aside, don't write anything. Mass of solution minus mass of solute. If I have mass of solution and I subtract the mass of solute from the mass of solution, I will get the mass of solvent. So mass of solution, I will write this as what? Mass of solution is equal to what? We have density, it is equal to mass by volume. And that is why mass will be equal to volume into density. So we can write density into volume. That is the mass of solution. Density of solution into the volume solution will give you the mass of solution. Minus the mass of solute is equal to how much? It has been already given, 20.7 grams. Right? Mass of solute. What is the density? It has been given 1 grams per ml. The density multiplied by the volume, which is 500 ml. And minus this will be 20.7 grams. Now you can easily see that we can cancel out ml and ml inverse, and this will be equal to 500 minus 20.7. 500 minus 20.7. 500 minus 20, it will be 480 minus 0.7.3. So this will be 479.3. 179.3 grams. Okay. If I want to convert this to kg, this will be equal to, I will now approximate a bit, right? I can now approximate a bit and I can write this as equal to 0.48 kg. Okay, so this is the mass of solvent in kg. Is this clear? Yes or no? Please tell me. Till here, all of you understand how we found mass of solvent? This is important. Mass of solution minus the mass of solute. Clear है कि नहीं? ये सबको जल्दी बताइए. Is it clear?
Yes, sir.
Yes. Okay, fine. Now what you need to do is just molality is equal to number of moles. What we have found number of moles as 20.7 upon 138. 20.7 upon 138. So this will be in terms of what? This is grams. This is okay. ये तो मोल आ जाएगा इसका हटा दीजिए, कोई दिक्कत नहीं है. Multiplied by 0.48 mean moles per kg. Okay. Now how will you solve this? 20.7 okay. तो आना चाहिए अब तो 138 into 0.48. I can write it as 48 upon 100. Below 100 है तो वो ऊपर चला जाएगा, right? If you have 100 in the denominator of denominator, it will go to the numerator. It will be equal to 100 like this. So this will be equal to 2070 divided by 138 into 48. चलिए इसको solve कीजिए. Let me know the answer. Assalamu alaikum Atif, how are you? अच्छा, Atif came here, he left. थोड़ी देर भी नहीं रहा है वो तो. Send the answer in chat after dividing. Whatever answer you get, it will be in terms of moles per kg. Okay. If someone has got the answer, let us see. No, I don't think so, Josefa. कुछ approximation कर दिया लगता है आपने. नहीं 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 नहीं. You have done some approximation. Try it once more. So let us see. 138 is there, है ना? So 140 इसको assume कर सकते हैं आप, right? We have around 14. Okay. 14 is there, and in the numerator you can assume that what is there? 207 is there. Okay. Then you have to divide it. So if you have something like this, 207 divided by 14, ये तो आसानी से कर सकते थे आप ना. So this will be equal to how much? This will be equal to 1. 14 ones are, right? 14 ones are 14 and 67 will be there. So 67. So for 67, what will be you doing? What is 14 fours are? 14 fours is 56, right? So somewhere around 1 4 it will be, right? 0 point. So ये जो आपका करके आएगा, this will be equal to how much? This will be equal to 14. ठीक है? Approximately it will be equal to 14. Then you have 14 upon 48. 14 upon 48. 14 upon 48 will be equal to 7 सा 48 will be 24, है ना? अब तो कैलकुलेट कर लीजिए आसानी से. 7 upon 24 you have
0.3.
0.313. अच्छा, एक और चीज आप लोग को हम बता देते हैं, इसको नोट डाउन कर लीजिए बिल्कुल. At least 2 non-zero digits after the decimal point. Okay, after the decimal point. That means if you have 0.006, नहीं ऐसे लिखना है आपको. आपके पास क्या आना चाहिए? 0.006. उसके बाद जो लिख दीजिएगा, फॉर एग्जाम्पल लेट अस इट इज 1, तो ऐसे लिख दीजिएगा आप, नहीं. लेकिन अगर आपके पास मान लीजिए इस तरह से कुछ आ रहा है 0.006 and then you are getting again 0, then it is fine. Okay, then it is fine. But you always have to see that एक decimal point पर non zero digit आया, उसके बाद कोई ना कोई नंबर होना ही चाहिए. ठीक है? You don't stop at the first non-zero digit after decimal point. Don't stop dividing as soon as you get the first non-zero number, non-zero digit after decimal point. Okay, please remember this. Please remember this. Okay, can I move on? Yes or no? Please tell me. आगे बढ़े. Molality is done, right? Molality is done. अरे हाँ या ना तो बोलिए, आवाज नहीं आ रही है. What is happening? Adriel, Alida, Fatima, Huzaifa, Rushda and Sara.
Yes, sir.
Yes. Okay.
Yes.
Okay. समझ में आ रहा है, हाँ या ना? अरे समझ में आ रहा है, yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, thank you very much. Mole fraction. Now, mole fraction, it is represented by the term, by a letter rather, Greek letter, which looks like X. We have alpha, beta, gamma. Alpha looks like A, beta looks like B, and gamma looks like Y. But we don't say it as A, B, or C. ना इस तरह मोल फ्रैक्शन को किसी ने अगर कहा है कि ये X होता है, तो ऐसी और क्या पता है हम. It is what? This is pronounced as chi. This is pronounced as what? Tell me. What is it pronounced as? Chi.
Chi.
What is it pronounced as? Chi. Okay. It looks like X, but it is not X. It is chi. It is chi. Now, what is mole fraction? Mole fraction is what? It is the ratio of the number of moles of a component to the sum of total number of moles of each component. Okay. So in binary solution, we have only two components, solute and solvent. In binary solution, I want to calculate the mole fraction of A, then it will be equal to the number of moles of A divided by the number of moles of A plus number of moles of B. The mole fraction of B, it will be equal to the number of O. ये उल्टा लिख दिया यहाँ पे हमने, number of moles of A लिखना था यहाँ. Sorry, my bad. Number of moles of B divided by number of moles of A plus number of moles of B also. I don't know whether you remember or not, but you must know that the mole fraction, the sum of mole fraction of a solution, that means for binary solution, we have chi A plus chi B. This will be equal to how much? Tell me. Chi A plus chi B will be equal to, किसी को याद है? 11th से नहीं याद है. Yes, Adriel, Alida, Fatima, Huzaifa, Rushda. Chi A plus chi B, it will be equal to, yeah, correct, Huzaifa. It will be equal to 1. Now tell me, should I prove this? Yes or no? Should I prove this? Yes or no? Please say yes. कोई भी. Please say yes, anyone, if you want me to prove this. Chi A plus chi B is equal to 1. किसी को नहीं चाहिए? Adriel, Alida, Fatima.
Sir.
No? Okay. Rushda, what about you?
No, sir.
Yes? Okay. Okay, who will explain it to Rushda? Alida, आप बताइए. How is chi A plus chi B equal to 1? Turn the mic on, Alida. Yes, Alida, what happened?
Yes, sir. I don't know how to explain it.
Why? Why you don't know?
I know the formula, but I don't know how to
ये
explain
formula
it.
नहीं है. This is not a formula. There
Like,
are
it's
only definitions.
It's
No, listen, very,
defined.
listen. It is not defined as that. It is defined as mole fraction is defined as the number of ratio of the number of moles of component to the sum of total number of moles of each component of the solution. ठीक है, चलिए. I will help Rushda. Rushda, we will not use pen, okay? Okay, Rushda, we will not use pen. आप imagine कीजिएगा, ठीक है? Okay. Can you see? I can substitute the value of chi A as NA upon NA plus B, है ना? chi A को हम लोग लिख सकते हैं. Keep your mic on, Rushda. Keep your mic on. NA upon NA plus B, right?
Yes.
And what will be chi B? NB upon.
NB upon NA plus NB.
Okay. So we have two terms. Fraction में है दोनों, and we are adding them, right?
Yes, sir.
Correct है? Okay. Are the denominators same?
Yes, sir.
So we can directly add them, है ना? Denominator को same रखते हुए. Then what will be the
Yes.
numerator? Numerator में भी क्या आ जाएगा? NA plus NB upon NA plus NB हो जाएगा. Yes or no?
Yes.
Then we can cancel both. Numerator में भी NA plus NB है, denominator में भी NA plus NB है. So if I said 3 plus 2 upon 3 plus 2, it will be equal to 1. Yes or no?
Yes, sir.
है ना? समझ में आई बात?
Yes.
Okay, great. 10. So also you can see, rather this question is not very much asked, but still mole fraction is also what? Mole fraction is also going to be temperature independent. Why? Because there is no volume term in it. There is no volume term in it. That is why it is going to be temperature independent. Okay, let us do one question. I think everyone is just done now. All of you have written definition and all. Yes or no?
sir.
Yes, sir.
Okay. चलिए सवाल लिखिए अब. Calculate the mole fraction of ethylene glycol in a solution containing 20% of ethylene glycol by mass. अब देखिए यहीं पर ट्रांसलेशन का इस्तेमाल होता है ना? You have been given a particular solution. Its concentration is given in the terms of mass percentage. Write the question first. The address is done. Okay, fine. So the first thing that we will be doing whenever you get this type of question, you will translate the information that is given to you. What is the information given to you? 20% of ethylene glycol C2H6O2 by mass. So it means 20 gram of C2H6O2 is mixed with 80 grams of what? Nothing is given, and that is why it will be H2O. 80 grams of H2O. Is this clear? Yes or no? Please tell me.
Yes, sir.
Okay. So what we are going to do? We are going to find out the number of moles of C2H6O2. We're going to find out the number of moles of H2O. 20 gram of C2H6O2. So number of moles. I will write this as solute, which will be equal to 20 upon. Carbon is 2. So 2 into 12 plus 6 plus 2 into oxygen is what? 16, right? Calculate कीजिए इसको 20 upon 24 plus 6 plus 32. ये होगा ना 24 plus 6 plus 16 to the 32. Then we have the number of moles of A, that is water. This will be equal to 80 upon the molar mass of water. You have to remember it is equal to 18, okay, grams per mole. This is equal to grams. You'll be getting this in terms of mole. ये भी आपका mole के terms में आएगा, ठीक है, grams and grams करके. चलिए सबसे पहले बताइए ये कितना आ रहा है. So भी 20 upon 62 हो जाएगा ना ये 62. ये 3.1 कैसे आएगा? ये न्यूमरेटर छोटा, डिनोमिनेटर बड़ा है. आप लोग कैसी बातें कर रहे हो हुज़ैफा आप? हाँ, किसके लिए बोल रहे हैं 3.1? NB या NA? किसी के भी नहीं आएगा वो तो. 3.1 NA वो भी नहीं होगा. 3.1 गलत है. 3.1 होगा ही नहीं. अरे 4 से चला जाएगा वो. 18 4 सा करिए. दिस विल बी इक्वल टू 4.44. तो साफ दिख रहा है बिल्कुल. ओके, दिस विल बी इक्वल टू 4.44. ये कितना होगा? 20 अपॉन 62. सो इसको बोल सकते हैं 2/6 है. 2/6 मतलब कि आपका 1/3, 1/3 मतलब कि आपका 0.33. सो 0.33 से थोड़ा कम, 0.32. Okay, so you have got the number of moles of A and number of moles of B, both of things, right? तो आप इसको छोटा कर लेते हैं. Now you can calculate the mole fraction of, let us say, B. It will be equal to 0.32 divided by 4.4 plus 0.32. ऊपर भी मोल होगा, नीचे भी मोल होगा. They all will cancel out each other and you will get this as 0.32 divided by 4.56. Then calculate this. इसको ऐसे लिख सकते हैं आप 32 upon 456. ठीक है, दोनों में you have 2 decimal points ना, you can remove them. That is like multiplying by 100 on numerator and denominator. जल्दी कैलकुलेट कीजिए. What is chi B? Then we will be calculating chi A. Don't be sitting there. Please calculate, okay? You've got one answer. हाँ चलिए चलेगा इतना चलेगा. So you must be getting this as 0.0068. हालिद अभी क्यों आ रहे हैं? हाँ ठीक है. So you are getting this as 0.70. ठीक है. ओके नहीं सॉरी 0.70 नहीं है 0.07 माय बैड. लिखने में गलती हो गई. 0.07. So what will be chi a? Who will tell me? Without calculating, who will tell me? Chi a कितना होगा? chi a जल्दी बताइए. chi a कितना होगा? It will be 1 minus chi b, right? Because chi a plus chi b is equal to 1. थोड़ा सा रिप्लेस करके आ जाएगा. 0.03 नहीं होगा 0.93 होगा ना हुज़ैफा? हाँ एड राइट करेक्ट. हाँ 0.93. ठीक है चलिए. ओके सो राइट दिस डाउन. उन्होंने नहीं लिखा अभी तक. Write this down, okay? Also, one more information for you guys that on 15th of May, that is Sunday, you will be having a test on concentration terms, okay? So whatever we have learned till now, the next class will be completely for numericals, okay? And in that we will introduce the term that is normality, but normality will be not there in the test. So concentration term, we'll be talking about mass percentage, we'll be talking W by W. We'll be talking about V by V. We will be talking about mass by volume, है ना? Mole fraction, molality, each of these things. Okay, and this will be a MCQ test. Okay, guys, clear? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay.